Okay, so in this chapter, we're going to be talking about linear functions, and this chapter only has the two sections that we're going to cover. We have had some linear functions when we were talking about our toolkit functions. The constant function, that's a linear function, and the identity function, that's also a linear function, okay? So linear functions graph to be what we say is a straight line. A lot of times we say that. I don't know where that crazy little thing came from. So a line like that, or maybe a line like that. Okay, so an example of where we might apply a linear function is, we're going to look at the example of distance. So the distances that you travel is based on your rate, how fast you're going, times time. So we have a formula in math that says distance equals rate times time, okay? So if you're traveling 60 miles an hour and you drive for 5 hours, you will have gone 300 miles. Okay, so as a function, we're saying the distance is dependent on your rate times time. Well, let's say you're going 60 miles an hour. So you take 60 times the amount of time you're going to be traveling, and then you'll know how far you went, okay? So that's an example. If you traveled for half an hour, you would have only gone 30 miles. If you traveled for 10 hours, you would have gone 600 miles, okay? So it's this relationship of input, you're putting in the time, and you're getting out the distance, okay? So that's kind of an example. All right. You may have worked with some linear functions in the past. One form that we have to write a linear function is called the slope-intercept form. Now it's usually written this way, y equals mx plus b, where m stands for the slope and b stands for what we call the y-intercept, or where it crosses the y-axis, okay? You might also see this written in function notation, f of x equals mx plus b, okay? So a lot of times when we start out in algebra, we do it in terms of x and y, but then when we start learning about functions, you might see the function notation, okay? All right, what is the slope? Slope has to do with like how steep the line is. So you could have a really steep line like this, or you might have a kind of flat line like this. That has to do with slope, and it has to do with what's called the rate of change, which we've studied that. So when you're going from one point to another point, how far up are you going and how far over are you going? That's the slope. We say the slope is the rise over the run. You may remember hearing that before, okay? So it's also said to be the change in y over the change in x. So this is the y, you know, how much are you changing from one point to the next? Are you going up so much? And then this would be the x, how much over you're going, okay? We also have a slope formula that's based on 2 points. So y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So this would be another formula that you'd want to remember. You'll probably get a page of notes for your exams. So, you know, sometimes it's helpful to have those formulas handy. One thing about slope is it has to be constant, okay? So no matter what 2 points I pick, let's say I pick a point here, and I want to get to this point up here, that change in y and over that change in x has to equal the other one, okay? If they didn't, you would not get a straight line. So the slope has to be consistent, okay? That is for linear functions. All right, so we'll explain more as we go through the videos.